So for this one there is a ratio question. So there are 648 pupils in the school. The ratio of boys to girls is 4 to 5. How many girls are in this school? So we're looking at the ratio here. So boys to girls and 4 to 5 are put underneath there. So to work this out is we add our ratios up or parts up. So what we've got is 9 parts in total. For 4 parts are boys, 5 parts are girls, and we've got 9 parts altogether. What we need to do is find out what one part would be. So 648 divided by the 9 is 72. This is one part. So if 72 is one part, then we can find out what 4 parts are and 5 parts. But the question is asking for girls, so all we need to look at is the 5 parts part of it. So 72 times 5 is 360. And that's the answer to that one. There is 360 girls in this school. So question 10, it's instructions for a fizzy juice. So 3 parts of fruit juice and 7 parts of lemonade make fizzy juice. So Molly has 600 millilitres of fruit juice. She also has 1800 millilitres of lemonade. What is the maximum number of litres of fizzy juice she can make? Now there's a few ways you could do this, but we'll go through with what I've done here. So 600 divided by 3. So if 600 millilitres of fruit juice she has, and she needs, that would be your 3 parts. So what we want to do is find out what one part is. And we find out that one part is 200 millilitres. So if we need 3 parts and we need 7 parts, we find out that each part is 200 millilitres. We can see that we multiply 3 with 200 and we multiply 7 by 200, which gives 600 millilitres for fruit juice and 1400 millilitres for lemonade. And when we add those two together, we can see that that makes 2000 millilitres. So for 2000 millilitres, change that to litres, it's 2 litres. So the maximum number of litres of fizzy juice she can make is 2 litres. Okay, it says enlarge the rectangle shown using a scale factor of 2 and centre of enlargement 0, 0. So we start off with putting our point 0, 0 at the origin there. And this is what we've been given in the question, is this small rectangle. Now, but it says it's a scale factor of 2, so that means that the new rectangle would be 2 times bigger than this one. So we use the centre of enlargement to work this out. So we always count from the centre of enlargement to each point. So we can see it's 2 up and 2 across to get to this point here. So we multiply everything by 2. Instead of 2 up, it's going to be 4 up. Instead of 2 across, it's going to be 4 across. And we plot the point there. And that's the same for everything. So it's 2 up and 2 across for this point. So it's going to be 4 up and 4 across for the enlarged shape. Bottom one is 1 down and 2 across. So it's going to be 2 down and 4 across for the new point. And the same again. So it's 1 down, 2 across for this point here. So it's going to be 2 down and 4 across. And if you plot your points there or draw your lines, then basically that's your enlarged rectangle. Question 12 is an exchange rate question. So you can do it in various ways. For this, you can change everything to pounds and then compare with that, or you can change everything to euros and then compare. So there's a couple of different routes you could take with this one. What I've done is basically change everything to pounds. So you can see this one here, it says $28 and exchange rate is for every dollar it's 81 pence. So basically we just multiply 28 times 0.81, so that's your 81 pence changed to pounds. If we multiply that, we get £22.68. So Dave has £22.68. So then we look at Evie, and we can see it's 25 divided by 1.09. As you can see, she's got 25 euros, and the exchange rate is for every pound, it's €1.09. And we divide with these two. When we divide with these two, we've got 22.94, and this is what Evie has in pounds. So the next step is, because it says who paid more and by how much more, we find out by how much more is by taking those two away. And we find that they've paid more by 26 pence. So the final answer is that Evie paid more. You can see there that's a bigger value in pounds, and she paid more by 26 pence. So question 13 is a trial and improvement question. So they would give you x cubed plus 3x equals 25 and has a solution between 2 and 3. Use the trial and improvement method to find this solution. Give your answer correct to one decimal place. You must show all your working. So for this one, because the solution is between 2 and 3, we can actually do it halfway. So we can see that 2.5. Now all we're doing is taking this 2.5 and substituting it into here. So it's 2.5 cubed plus 3 times 2.5. And that would be 23.125, which when we compare it with 25 up here, it's a lot smaller, so that's too low here. So if it's too low, we're going to move up a little. So 2.5 moves to 2.6, and we do exactly the same. We substitute it into this expression, and we get 25.376. We check it with 25, and we can see it's too big or too high. So 2.5 is too small, and 2.6 is too big. Because the answer is to one decimal place, one of those answers here is going to be the right answer. So to determine which one it is, we do halfway between those two. So we do 2.55, and we just throw it into the expression again. So we've got 2.55 cubed plus 3 times 2.55, and we get 24.231. When we compare it to 25, we can see it is too low. So we can work out which one of 2.5 or 2.6 is the answer. Now I've drawn a little line here with 2.5 on 2.6 in each end and 2.55 in the middle. So we can see that this is too low and this is also too low, so the actual answer is closer to 2.6. So 2.6 would be the answer for this one. So we've got the nth term for this question 14. So the first four terms of a sequence are 2, 7, 12 and 17. Write down the expression for the nth term of the sequence. So we can see that we're adding 5 to each one. So 2 plus 5 is 7, 7 plus 5 is 12. So first of all, we put 5 in to start off with. Then we look for the previous number to 2. So we take away 5 for this one, and then we find that minus 3 would be the previous answer to 2, or the previous number in this sequence. So you would have 5n take away 3. So this is constructions. Question 15, PQRS is a rectangle. Shade the region inside the rectangle which is more than 5 centimeters from P. So it's from a point P. So you would use your compass for this one. So the first one here is 5 centimeters from P. So you get a compass and you would measure 5 centimeters on your compass. Once you've measured 5 centimeters on your compass, you would draw an arc from P. So this means that all of this in this side of the arc is all included. So we look at the next part. and more than 3 centimeters from line QR. Because it's a line, we can just use a ruler and measure 3 centimeters from Q here and mark it. Then we can measure 3 centimeters from R, mark it there, and then just draw a straight line. So when it says more than 3 centimeters, it's everything on the left-hand side of this straight line. So when we shade in, it's in between this arc and the straight line. Question 16 is a survey is carried out to find out the number of electric cars on the road. 100 cars are surveyed each day for 4 days. The results are recorded in the following table along with the relative frequencies so far. So these aren't consecutive totals, these are just individual totals for each day. So to get the relative frequency for 0.11 for day 1 is just 11 divided by 100. For 0.115, it's when we add these two up. So it's 11 plus 12, which is 23, divided by 200, which then becomes 0.115. So this is how we build it up for these relative frequencies here. So to find out the missing one, we can add everything up here, which is 48, and add everything here. So we've got 48 out of the 400 cars surveyed, and we can divide that, and that becomes 0.12. So the missing relative frequency there is 0.12. For question B, it said, what would be the best estimate for the probability that a car chosen at random is electric? Now, because there was 400 cars surveyed at the end of it, it would be 0.12 would be the best estimate to use, because the more trials you make, the more reliable it is. So we've done 400, we've taken 400 cars, which means it's going to be a bit more reliable than just taking a survey for 100.